Hey everybody, Mrs. Lindsay again with the last page of the factoring review. All right, so go ahead, jumping right into it. Number 15, it's got 4 terms, so it's a grouping problem. It's either a 2x2 or a 3x1. It looks like it's a 3x1, but I have to tell you, if you look at this right here, a lot of you might think it factors into this. And that is not quite the case. So let me go through. If you distribute this, FOIL, whatever term you'd like to use there, be 1 minus 3n, then be minus 3n plus 9n squared. That right there is the issue. So yes, it's a grouping problem, but we need to rearrange it. Okay. So if we can get this to be a positive 9n squared, it'll factor into this. And then maybe we might even have to do other adjustments because maybe it might have to be a plus in this case. But let's see what we can do. So if we move things around, so let's do the 1 right here, right? Let's make it so we have to factor out a negative. So make this so I take out that negative of the 9n squared. So then that means if I put the other ones in here, it's going to change their signs as well. So again, made this one positive, and this one positive. So now that does factor into 3n, in this case, plus m quantity squared. So now we get, let me just cross that off so you realize that didn't work. This again is a dots problem, so it'd be 1 goes in the first spot. Square root of this is just, again, that binomial. 1's positive, 1's negative. And again, you're welcome to leave it that way, or again, if you would like to distribute through that negative in the second set of parentheses, that is fine as well. Okay, so either of those answers would be fine. The actual last 3 problems are very, very similar to what we've already done. 16 is extremely similar to number 7. So take a peek at number 7 and try that one. Again, might have to rearrange and factor something out. 17 looks like a pretty straightforward grouping problem, and then 18 is a fairly straightforward problem as well. Might have to take out a GCF of some sort, kind of looking like problem number 2 maybe. So if you'd like, take a look at some of those, and then when you are ready, push play, and we can check the answers for that. So again, 16, you might want to refer to number 7. On the last problem there, 18, you might want to refer to number 2 if you're not quite sure how to do that. And our other grouping problem, which is a 2x2, 17, if you want to look at number 5, that's again a very similar problem there as well. Okay, so go ahead and pause the video. Okay, so for 16, first thing I did was rearrange it. And again, huge hint here to make life easier. If that is a negative, factor that out. Change your signs then within your trinomial. And now it's a much easier problem to solve. Factors of negative 45 that add up to 12 would be negative 3 and positive 15. 17, done part of this as well. This is a grouping problem. Group the first 2 together and the last 2. And again, remember this negative stays here with that x. So I factor out an x squared in the first set of parentheses. I factored out, since there's a negative there, you usually want to factor out that negative. I took out a negative 1. So then these were the common factors. However, I'm not finished. If you got to this point, that's awesome, but it continues to factor. This is another difference of 2 squares. It's another dots problem. So I'll bring that one down. This one factors into x plus 1, x minus 1. So again, you're welcome to leave it like that. Or again, take one extra step and simplify it slightly by using your exponent of 2 there. 18, GCF, took out a 5 first, And now, whenever you do that, makes, again, life easier working with smaller numbers. Makes this a leading coefficient of 1, so factors of 9 that add up to -6 are -3 and -3. Just like I did up in this previous problem, you are welcome to leave it like this or simplify it and write it as a quantity squared. Either one of those would be fine. Okay. And our very last problem is number 19. It only has 2 terms. This is one term, this is another term, because again, terms are separated by addition or subtraction. But it's not a perfect square, it's a perfect cube. So this is a SOAP problem. The cube root of x plus 5 cubed is simply just x plus 5. Okay, so when we make our binomial here, the binomial is in the first one. That'd be what goes in the first spot. The second spot is, again, what is the cube root of 216? Using your calculator, or if you happen to know, that would be 6. So that's going to go there. Now we have our trinomial over here. So again, what goes in that first spot? X plus 5, quantity squared. The middle spot is multiply those two together. So I'll simply just write it as 6 times the quantity x plus 5. And then the last spot would be, again, this 6 quantity squared. And SOAP, same as the original. Opposite of what I just wrote. Always positive. And now we just need to clean this up just a little bit. Here we can add. I'm going to actually multiply that out, so that would be x squared plus 10x plus 25. And now I'm going to distribute through here, but it needs to make sure that I distribute through that -6. So it's going to be -6x minus 30, and then that'd be plus 36. And a little bit more cleaning up here. So we'll have x squared. Then I have some like terms, 10x minus 6x, which would give me positive 4x. And then all these 25 minus 30 would be -5, plus 36, which would be 31. And it looks like this might factor, but again, we know there are no factors of 31 that add up to 4 because this leading coefficient is 1. So that is the final product. Okay. And this concludes factoring review for page number 4.